Here we're being asked to find the exact value of sine u plus v. We're given that sine of u is equal to 5 over 13 and the cosine of v is equal to negative 3/5. We're also told that both u and v are in quadrant 2. We know that sine of u plus v is equal to sine u cosine v plus cosine of u and sine of v. We're given sine u and cosine v. So all we need to find now is cosine u and sine v. We have sine u, which we know is our opposite over our hypotenuse. Here I've drawn a triangle for sine u, or opposite than our hypotenuse. So from our Pythagorean theorem, we know that the adjacent would be the square root of 13 squared minus 5 squared, which comes out to be 12. So cosine of u then would be 12 over 13. Now we're told that our angles are both in quadrant 2, and we know cosine is negative in quadrant 2, so this is negative 12, 13. So now we have cosine u. We now need to find sine v. Cosine v is negative 3/5, so our adjacent is 3, our hypotenuse is 5. Using our Pythagorean theorem again, we get our opposite being 4. So sine of v would be 4 over 5. So now it's just a matter of filling this. We have sine of u plus v would be equal to sine u times cosine v plus cosine of u, which would be negative 12, 13 times sine of v, which would be 4/5. So here we have negative 15 over 65 minus 48 over 65, which gives us negative 63 over 65. So the sine of u plus v is equal to negative 63 over 65. Here we're being asked to write this trigonometric expression as an algebraic expression. And the trig expression is the sine of arctan of 2x minus the arc cosine of x. Now this is the same thing as our difference of cosine, where arctan of 2x is our u and the arc cosine of x is our v. So using our difference formula, this becomes the sine of arctan of 2x times the cosine of arc cosine of x minus the cosine arctan of 2x times the sine of arc cosine of x. Since this is our u and this is 2x over 1, we know the angle u is, the tan of angle u is our opposite over our adjacent. Using our Pythagorean theorem, we can find the hypotenuse. We know the hypotenuse is equal to the square root of 2x squared, which is 4x squared, plus 1 squared, which is 1. So now we can find the sine of u. The sine of u would be the opposite over the hypotenuse. So this gives us 2x over the square root of 4x squared plus 1. And we're going to times this by the cosine of the arc cosine of x. We know from our identities that the cosine of arc cosine of x is simply x. So this becomes times x minus the cosine of the arctan of 2x. Once again, this is our u. So the cosine of u would be the adjacent over the hypotenuse. So this becomes 1 over the square root of 4x squared plus 1. We're going to times that by the sine of the arc cosine of x. This is our v. Drawn our, so here we know x cosine of x would be the adjacent over the hypotenuse. So if this is our adjacent, this is our hypotenuse. The opposite side would be the square root of 1 squared minus x squared. So now we can find the sine of v. The sine of v is equal to the opposite over the hypotenuse. So this becomes the square root of 1 minus x squared all over 1. We can simplify this. It's 2x times x would give us 2x to the second power, and this is all over the square root of 4x squared plus 1 minus this 1 times this will be the square root of 1 minus x squared all over the square root of 4x squared plus 1. Now since our denominators are the same, we can go ahead and combine these two fractions, which gives us 2x squared minus square root of 1 minus x squared all over the square root of 4x squared plus 1. So the algebraic expression that is equivalent to this trigonometric expression is this. Here we're being asked to prove the identity that the sine of pi over 6 plus x is equal to 1/2 times cosine of x plus the square root of 3 times sine of x. We can use our sum and difference formula again. This is our u and this is our v. So we can expand this, so this becomes sine of pi over 6 cosine of x plus the cosine of pi over 6 sine of x. We know the sine of pi over 6 from our unit circle is 1/2, so this becomes 1/2 cosine of x plus the cosine of pi over 6 from our unit circle is the square root of 3 over 2 times the sine of x. If we factor out the 1/2, we're left with 1/2 cosine of x plus the square root of 3 sine of x, which is the same thing as this. Once again, we're being asked to prove an identity. This time the identity is sine of x plus y times the sine of x minus y is equal to sine squared x minus sine squared y. So we're using both our sum and difference formula for sine. So this becomes sine x cosine y plus cosine of x sine of y. So all this will give us this piece down here. And when we expand this, this becomes sine x cosine y minus cosine of x sine of y. So this piece will give us this. So this is what we have on our left side so far. If we distribute this, this times this, this times this, this times this, and this times this simplifies to give us sine squared x cosine squared y minus cosine squared x and sine squared y. Now we know from our Pythagorean identity that cosine squared x is equal to 1 minus sine squared x, or in this case cosine squared y is equal to 1 minus sine squared y. So we can replace cosine squared y with 1 minus sine squared y. Similarly, we can replace cosine squared x with 1 minus sine squared x. Now if we distribute the sine squared x, this becomes sine squared x minus sine squared x sine squared y. If we distribute our sine, this becomes a negative 1 and this becomes a positive sine x, and then we times it by this. This will end up being a negative sine squared y plus sine squared x sine squared y. Here we can see that sine squared x sine squared y is negative and this one is positive, so these two will cancel out, leaving us with simply sine squared of x minus sine squared of y, which is our original problem. So here we have proven this identity. Here we're being asked to find the solution to this equation in the interval of 0 to 2 pi. Our equation is the sine of x plus pi minus the sine of x minus 1 is equal to 0. Here this is the sum of a sine, so we can expand this using our sum identity. So this becomes the sine of x cosine of pi plus the cosine of x times the sine of pi. Then we're going to still have our minus sine x minus 1 is equal to 0. Now we can evaluate the sine, cosine of pi and the sine of pi from our unit circle. You know the cosine of pi is negative 1, so this becomes negative 1 times sine x, so this is negative sine x. The sine of pi would be 0, so this is 0 times cosine x, so this goes away. So this becomes minus sine of x minus 1 is equal to 0. These are like terms, so we can combine them. So this becomes negative 2 sine of x minus 1 is equal to 0. If we move over sine, then we have negative 1 is equal to 2 sine of x. Dividing both sides by 2, we have sine of x is equal to negative 1/2. So here we're trying to find the angles whose sine is equal to negative 1/2. We know sine is negative in the third and fourth quadrant, and where sine is negative 1/2 in the third and fourth quadrant is when the angle is equal to 7 pi over 6 and 11 pi over 6. So here we have our two solutions of this equation within the interval from 0 to 2 pi.